Well, hello there. This is Dr. Clark, and we're here in this video to review the heart cycle because sometimes it's just helpful to have an extra chance to look through the different steps of the cycle. Fair warning, there is a non-zero chance that one or more cats might interrupt what we're doing, but that's the nature of internet videos, so if that happens, we'll deal with it as it comes along. So first we need to get reoriented to structures in the heart. This is a photo image of a heart. Up at the top, we've got the two atria. Right, and since we're facing this, the left atrium is on our right. So here's our left atrium. And our right atrium is on the left, right? We're mostly going to focus on events taking place in the systemic portion of the heart. So that's the left atrium and then the left ventricle. All right, over here on the other half of this slide, I've got a diagram of pressure forces in a couple of key locations over time on the x-axis. And since this is a cycle, once this cycle completes, it will loop back around to the beginning. So we're starting at a somewhat arbitrary point, but for a good reason. So our y-axis here is pressure, and we're tracking pressure forces in three different locations. So in the atrium, in the ventricle, and then in the aorta, right after blood leaves the ventricle. All right, and just in general, it's helpful to think in terms of whether muscle tissue is contracting or relaxing. So if muscle tissue is contracting, that tissue is said to be in systole. If it is relaxing, it's said to be in diastole. And for most of what I'll be talking about, I'm going to be referring to ventricular systole and ventricular diastole, right? So these are what we would measure for looking at someone's blood pressure overall. But the atria also contract, so we'll see atrial systole enter the picture at a certain point. But we're going to start out at the stage where the ventricle starts to contract. And so that is the phase that's taking place over here between these two dotted lines. And when the ventricle first starts to contract, notice what's happening to pressure forces within the ventricle over the course of this part of the heart cycle. We've gone from a relatively low pressure in the ventricle to increasing pressure. But during this first stage of contraction, there's an increase in pressure, but there's no movement of blood. And so the volume of blood that's inside of the ventricle during this first stage is constant. And for that reason, this portion of the heart cycle is referred to as iso, or same volumetric contraction. Right? So we're seeing contraction, increase in pressure, but we're not seeing any movement of blood. So let's just note no movement yet. Okay? But notice by the end of isovolumetric contraction, at that point, that very point, there's a crossover where the pressure force in the ventricle is equal to the pressure of the aorta. And so that leads into the next stage of the heart cycle. So at this point, once pressure in the ventricle, so let's say pressure in the ventricle is greater than pressure in the aorta, right? That means now there's a pressure gradient, so it's possible for blood to start flowing. So blood is going to move from the ventricle into the aorta. And I should also highlight, in order for that to start happening, there is a valve positioned between the ventricle and the aorta. On this diagram here, I've illustrated the pulmonary valve, so that's on the right side of the heart, part of the pulmonary circuit for the pulmonary aorta. And the pulmonary valve looks somewhat like the aortic valve. This is a two-dimensional drawing of a three-dimensional structure, so the aortic valve is actually deep to the pulmonary valve. We can't really see it, but it's coming back up in through here, heading towards the aorta. So at this crossover point, what's going to happen is the pressure from the ventricle is going to push open the aortic valve, right? So at this point is where the aortic valve is going to open, And then we're going to have start to see the movement of fluid. So in the second part of the heart cycle here, right, this phase is ventricular ejection. So blood is flowing from the ventricle into the aorta. And now notice some of the other details of what's happening here. So we still see an increase in pressure. So the ventricle is continuing to contract, but after a point, it runs out of room. It can't contract anymore. And so pressure forces start to drop in the ventricle. Oh, and we do have a cat contributing. He's feeling the pressure forces drop in his ventricle. So at this point, the pressure in the ventricle drops below the pressure in the aorta. And if we were just considering pressure, right, we'd predict that we wouldn't see any more movement of blood into the aorta, right, at this point where we've crossed back under the aortic blood pressure. But I've got a note here that says blood still moves into the aorta here. Why does that happen? Well, this is the one spot where we really have to think about fluid kinetic energy. Right, so the blood that has been in the ventricle has kinetic energy from being squeezed, and that kinetic energy means that the total fluid energy for blood in the ventricle is still higher than the fluid energy of blood in the aorta, so there will still be net movement from the ventricle into the aorta, right? So out of the heart and into the systemic circuit overall. Okay, so that's going to work up to a point, but there will then be a point where the total fluid energy in the ventricle falls below the total fluid energy in the aorta. And along with that, the ventricle's going to have contracted as far as it can, so it doesn't really have any further that it can go. So at that point, we're going to shift into the next stage of the heart cycle. All right, so at this point, we're seeing a continued drop in pressure in the ventricle. And this is the muscle of the ventricle starting to relax. So we've gone from ventricular systole, which is taking place across the first two phases. And now we are entering ventricular diastole, right? Relaxation of the ventricle in this next phase. So once we hit this pressure point where the total fluid energy from the ventricle is too low, and there's also not much blood left anyway to move into the aorta, what's going to happen then is the aortic valve, it's one of these one-way valves, it's going to slam closed, okay? So here's the point where the aortic valve slams closed, okay? And the force of the aortic valve slamming closed is actually so powerful that it causes an additional pressure pulse in the aorta, right? So this pressure pulse is caused by the aortic valve closing. Okay, and then you can see past this point, the pressure in the aorta starts to drop. And won't recover until we get all the way back around to ventricular ejection again. Okay, so the isovolumetric relaxation phase is taking place. Here's the first part of ventricular diastole, and again we have this word isovolumetric, right? So that should be a clue that during this phase we've got relaxation of the muscle tissue of the ventricle, but we don't have any change of volume. We don't have any movement of blood in the ventricle. So let's just note, no blood moving yet. But notice, by the time we get to the end of isovolumetric relaxation down here, now we're starting to see another crossover point where pressure in the ventricle is falling below pressure in our other compartment to think about, the atrium. Okay, so here's our atrial blood pressure. So by the end of isovolumetric relaxation, so we've got this crossover point. The pressure in the ventricle is now going to be below the pressure in the atrium, right? Which in this illustration, again, because this is the systemic heart, the atrium is going to be located to the rear here. Okay. Okay, so now, hopefully from having seen what's happened over the course of ventricular ejection, you might have some ideas about what we might start observing when we hit this crossover point at the end of isovolumetric relaxation. And indeed, in this next portion of the heart cycle, we're going to start seeing net movement of blood from the atrium into the ventricle. So this phase is referred to as ventricular filling. So blood flows from the atrium to the ventricle. Okay, and so for that to happen, there's also the opening of another valve, right? So up here we're looking at and thinking about the aortic valve opening and the aortic valve closing. Down here, we're now dealing with the valve that's found in between the atrium and the ventricle. There are special fancy anatomical terms for the two valves located on either side of the heart, but just based on the shapes of those valves. So the tricuspid valve, so it has three prongs to it, we could say, three projections to it, so hence tri for tricuspid valve. And then on the systemic side, we have a valve that has just two elements to it. So it's called the mitral valve because it's like the hats worn by clergy, mitral hats. But in the big picture, we're not an anatomy class, we're a physiology class, so we can use a more generic name for these valves, and I like the one that's very descriptive of exactly where they're located. So we're going to refer to these valves as the atrioventricular valves, right? So that's the valve, one-way valve that separates the atrium from the ventricle. So when we hit this crossover point where ventricular pressure falls below pressure in the atrium, that's the point in time where the atrioventricular valve will open, and then that's going to allow blood to flow from the atrium into the ventricle. And again, just as a reminder, right, we're still in ventricular diastole here. All right, and another point, the major pressure force that's causing blood to flow from the atrium to the ventricle in this stage, it's actually not squeezing so much as it is just gravity and the pressure from venous return to the heart, right? So let's just note that our motive force, our force for movement, is largely venous return of blood to the heart. And I'm pointing that out because of what we're going to observe in the next stage. So this works up to a point, but at some point, the blood that has already entered into the ventricle, it's not completely inert, it has pressure. So at this stage, you might notice we're getting very close in pressure forces between the atrium and the ventricle. So the flow of blood is going to slow. So that's going to cause us to wrap back around here to the start of our heart cycle diagram, to the final phase, which is the phase of atrial systole, right? So this is where the atrium is going to contract, okay? And so it's going to finish off the emptying of the atrium into the ventricle. That's kind of how I like to think about it. It gives a little squeeze or a little kick at the end, so push out that last bit of blood. And then once that's been accomplished, the atrium is going to relax. So actually the rest of this whole process, the atrium is going to be in diastole, right? It's relaxing, it's stretching. It's going to experience a little bit of rebound just based on other circulatory events. We're not going to dwell too much on that. So after the atrium is finished contracting, then we're going to see another wave of contraction hit the ventricle, and then we're back at the start of the heart cycle again, right? So isovolumetric contraction, opening of the aortic valve, ventricular ejection, aortic valve closing, now isovolumetric relaxation, and then the atrioventricular valve opening, right? Then ventricular filling, right, which is largely a passive driven by venous return, finished with atrial systole, to kick the rest of the blood back into the ventricle, and then we start the whole cycle all over again. Just like that.